All right, we are doing the next part 4. We're going to be reacting iron with sulfur. The best part of this is right at the end, by the way, so be attentive. I've got the iron and sulfur. Okay, so we're going to be doing the properties of iron and sulfur right here in this data table. And then we're going to be looking at the observation of the reaction when they're not heated and recording something, and then we're going to be recording a lot down here as it heats up. So let's just have a look at the iron and sulfur. So right there, in the test tube, I've got some iron, which is at the bottom. It's a brown solid, and it's kind of granular. And then the sulfur is a yellow powder. It's almost like powdered sugar in consistency, and it's yellow. And I've actually got roughly equal amounts in there. Now you're looking at it going, well, it's not equal at all because they're not the same size. Well, they're not even the same mass. They're roughly about the same in terms of the number of atoms. So what I'm going to do is I'm going to shake this thing up a little bit, and then we'll observe some properties when they're not heated. So that's what I'm doing off camera right now, is I am combining them. And so there we go. I've got them combined. And I use my thumb, so I want to rinse off my thumb because I don't like having sulfur on my thumb. All right, so now let's have a look at the combination, and it looks like a brown powdery thing that has coated the whole entire test tube, but I can do something cool with a magnet. I can, with this magnet, you can see the magnet right there. This is not going to show up that well on the screen, but I can use the magnet and I can separate out the iron from the sulfur. I think you can kind of see that right there. Look at that electrical field, or that magnetic field that you can see, because the iron is lining up in the confines of the electrical or the magnetic field. So there's a high proportion of iron up in here, and then the bottom is more sulfury. So we could, if we wanted to, we could separate them, but we're not going to do that. But instead, we're going to heat this thing up, and we will see what happens. I'm going to shift this stuff over. I don't know that you can see the flame on the Bunsen burner, but there it is. And so now it's time to heat things up. So I want to adjust the camera, but if I adjust the camera, it's going to get way off. I'm just going to put the mixture in the flame, and I will have to describe what's going on. And you can see that it might be getting a little bit darker. So yeah, you can see that it's become darker, and there's some bubbling occurring right now. There's this brownish liquid that is bubbling. And now there's some vapors coming out of the top that are a little yellowish in color. Now, those vapors coming out of the top, that's a bunch of sulfur. And if I put this down there, I can get it to burn. But I don't necessarily want to do that. I'm just going to keep heating this thing up. And because I'm producing some sulfur, it's going to stink. It stinks like fireworks right now. Do you see the yellow right in here? There's some yellow along the side of the test tube. But what I need to do is turn on the fan, so it's going to get a little bit loud. I will just continue heating. So what we have is there's a brown liquid that's kind of bubbling. I see some yellow smoke coming out of the top. We have to heat this thing up until we get a nice glowing red substance in the test tube. And so that might take a while. Which is why we're on a separate this is on a separate video because already we're at the 5-minute mark. And like I said, the best part is the end. Now I see that at the bottom of the test tube you can see the redness that's forming at the bottom of the test tube. And as soon as the whole bottom of the test tube is reddish in color, I am gonna end the experiment. So now you can see the redness. I'm hoping you can see the redness. You can get a glimpse of it. There's redness at the bottom of the test tube. Just above it, it's a gray layer of powder. Then it's the brown liquid, and then at the very top of all the substances, there's some very active yellow gas that's being produced. And you can see pretty clearly that there's this red solid at the bottom. I'm just going to keep heating that for just a little bit longer. And then what I'm going to do to get the solid out, I have to put it into the water. I pretty much have to break the test tube, and when I break the test tube, that's the coolest part of this. So I think I'm just about done. So here we go. I'm going to put it in the water. Just watch carefully. All right. So there's the end product. Now I need to get the substance out of there, but I've got a bunch of other ones from previous years that I'm going to show you. So this is what we get out of it. It's a solid, and there's a bunch of bright crystals here, and they're gold in color. And what we've created is fool's gold. We've created some iron sulfide, and you can kind of get an idea that when I turn it on an edge, you can see that right there, you can see this shiny part, and that shiny part is part of the crystal. So there's a bunch of gold crystals that we produced, and it's very solid. And is it magnetic? Well, yes, it's magnetic, because look at that, the magnet is still sticking to it. All right, so observations. Let's just have a look at the data table before we end the video. And look at that, my battery's down to 5%. Okay, so iron, it's a brown solid granular. Sulfur, it's a yellow solid like powdered sugar. When they weren't heated, when I just kind of shook them up together, there was just a brown crusty stuff that didn't really change too much. They just mixed together. But upon heating, just a summary, a yellow smoke was created. There was a brown liquid that was bubbling. Eventually we had this red glowing pellet that formed in the bottom, and then the end product has gold crystals. So there is the end of our Recognizing Reactions lab. What you can do right now is start working on the analysis questions and check the agenda for anything else. Now, by the way, right here, we did the thing with the, it's in the bag lab where we kind of predicted. I want you to do the same thing here. Make your best prediction as to what the substances can be. And remember, positive ions will go with negative ions. Negatives can go with other negatives. But just the whole idea of a chemical reaction is that things group together differently. So just make your best guess. I don't care if you're right. I don't care if you're wrong. I just want you to go through the process of predicting what the products would be. And you should be able to look at these formulas and go, okay, silver's a positive ion. Nitrate is a negative ion. Sodium is a positive ion. Chloride is a negative ion. So in a chemical reaction, they're just going to switch around and group together differently. So how would you group them differently? Same thing here. Magnesium makes a positive. Hydrogen's a positive. Chloride is a negative. How can you recombine these so that you produce two different substances? And then here it's just a matter of getting oxidation numbers and doing the old switcheroony. By the way, the iron here is going to be a 2+. Iron here is 2+. All right, so make your best shot. And again, for this is like a really important question. Make your best guess. And I don't really care if you're right. I don't really care if you're wrong. I want you to go through the process. All right, I will see you all on Thursday. But no, I won't. I'll see Hybrid B on Thursday. All right, see you later.